All creatures, however small, have a home of some kind. It may not suit you or me, but for them it's fine. Around them is a place they don't think about, but which we have learned to think about a great deal. It's called the environment. In any environment, alongside the plants and wild creatures of nature, are found the works of man.
Check the metal detector M101. Check the metal detector M101.
Just north of the Tropic of Capricorn in Western Australia is a huge and beautiful area known as the Pilbara. Over the past 8 years or so, close to 200 million tons of Pilbara rock has been dug out of the ground by one mining company and exported all over the world. That may sound a lot, but iron ore is heavy stuff, and the mine itself is only a pinprick on the Pilbara landscape. Any mining operation, of course, must have some effect on the environment. Today, as the demand for steel keeps increasing, mining operations must keep growing. That's what people call progress. And progress can be thoughtless. The environment may suffer. But we're going to look at one mining operation that is researching the environment in detail to ensure that progress means growing with care. Eight years ago, this town, called Newman, was built by a mining company in a remote area of the Pilbara. At first, the town was new and bare. They planted 70,000 trees. At that time, of course, you couldn't see the trees from up here. Today, it's easier to see the trees than the houses. It's a nice, shady town today. As new houses go up, the trees keep going in.
It's a clean town, with hardly any pollution from the mine.
Hugh Jones, Environmental Superintendent.
Now that we are planning to expand our town and our operation, we want to make certain the town remains clean. While dust is a major problem in the industry, we're also concerned about the other effects of our operation on the environment. We are concerned about possible effects of our mine and our port on the native plants and animals that live in that area. We're also concerned about the effect of our railroad line, which connects the two ends of our operation. When we first arrived in the area, there was no information available on the native plants and animals, and in order that we may formulate a management policy, we have employed a series of experts to go out and advise us on the native plants and animals and the effects of our operation on them.
Dust is not the only problem here, of course, but it's one which can affect the quality of life in the town, And it can also affect the local vegetation in a hot semi-desert area like this one. Dust is carried by wind, and an intensive study of wind patterns is being carried out so that plans for town expansion and a new ore body development can avoid the problems of wind-borne dust in living and working areas. Anemometers at strategic points give a continuing flow of information on wind strength and direction. This is another method of obtaining wind information. Very practical and very effective. The wind doesn't only blow dust towards places, it also blows it from places, such as waste dumps. These dumps are necessary to dispose of huge quantities of waste material, but they're always affected by erosion from wind and water, and their contents need to be stabilized.
The best way of stabilizing waste dumps is to get a complete cover of vegetation over them.
Dr. Roger Black, consulting agronomist.
In this way, you cut down water and wind erosion, and also the waste dumps will look a lot better. In rehabilitation work of this nature, it is important to take account of the growing seasons of the area. In this case, we have two growing seasons, a summer growing season and a winter growing season. In front of us, we see the mature summer growing grass species that were used in the trial, Rhodes grass and buffel grasses. Behind us in these plots, we have the early germination of the winter growing species and varieties that are being used in the trial. The aim of the trial is to produce a self-perpetuating plant community on the waste, in which native plants will dominate. Agricultural techniques, particularly irrigation, have to be used to attain an initial effective cover of pioneer vegetation, and thus speed up the process of waste heap rehabilitation. These techniques must be limited to the early phases of the work to reduce costs. The established vegetation must then be capable of looking after itself.
Some good results were achieved by spreading native topsoil over the waste and watering it. Seeds in the topsoil germinated well, and time will judge the ultimate results. In the meantime, the pastoral grasses have taken a good hold and should provide a good foundation for future seed germination. Results of the revegetation experiment are so far encouraging.
Inevitably, the mining operation causes fairly extensive downgrading of plants and trees in the immediate vicinity of the mine.
Dr. Neville Marchant, botanist, West Australian Herbarium.
It is surprising, though, how some species have adapted to dusty, disturbed conditions. For example, some of the cassias and this Eucalyptus gammophylla. These should really be encouraged to prevent further erosion. We were interested in the plant species occurring in the mine site and around the town, and in order to study the distribution of these, we used aerial photographs, infrared aerial photographs, which were taken by the company. This enabled us to pinpoint even small bushes and to pinpoint the larger trees which make up the ecological communities. In adjacent areas, such as one of the ore bodies to be developed, the vegetation has already been downgraded. This is because burning has been too frequent and there has been overgrazing when the area was pastoral land, and too many of the shrubs just haven't been able to rehabilitate themselves.
Even the most gloomy and barren-looking stretches of bush have a beauty, which cannot be fully appreciated without looking at it closely. After showers, small flowers pop up out of the ground, punctuating the red Pilbara soil with tiny splashes of colour. Showers may bring flowers, but rain is too spasmodic to control the dust resulting from mining operations. So water is sprayed onto the benches, onto the haul roads, around the crusher, and in fact anywhere that could be a dust problem. This job requires up to 2 million gallons of water every day. The question is, where does it come from? And how long will it last at this rate of usage?
Water is most important to us. It's almost as important as iron ore.
Bill Willis, Chief Geologist, Mount Newman Mining Company.
The management of the water must be undertaken in a thoroughly professional manner so that we know exactly how much water we have, how much water we're using. The water is found by exploration drilling, and this is undertaken by fairly sophisticated rigs drilling through the gravels into the water-bearing strata, locating casing, then blowing the water from the casing to determine its quantity and quality. Having done this and established a well field, it's then time to start seriously looking at how we're affecting the well field by pumping. We have 150 bores scattered through this area, which we monitor on a fortnightly basis. These are done by a chap going around with a water depth probe and determining the levels of the water in the aquifer. From these levels we can deduce the amount of drawdown in the area or the amount of recharge due to rainfall.
The concentration of water near the mine has led to some animals and birds and reptiles coming to live quite close to the town. From emus in the bush to emus carved in rock. In many remote areas of Western Australia, there are historic reminders of the Aboriginal culture, such as these rock engravings close to the Mount Newman Railroad.
Western Australia has an Aboriginal Heritage Act. Under this Act, anyone who's carrying out an activity which may interfere with an Aboriginal site is obliged to seek permission to do so.
Dr. Bruce Wright, anthropologist, WA Museum.
It's our job to establish the significance of these sites, either from the point of view of living Aborigines or from the point of view of the science of anthropology and archaeology.
The museum team had to decide whether or not a rock shelter close to a proposed ore body development should be preserved.
Something burning in situ? Yes. Or it's a heart? I wonder whether you'd like to have a look at some of it? It's got sort of angular facets, but we're...
That conchoidal fractures. Oh, yes, it's totally...
Leslie Maynard, archaeologist.
We found numbers of these stone flakes, which could have been used by prehistoric people for cutting up meat. And, in fact, we think that animals probably were cooked at this shelter, because in the deposit there show up numbers of these hearths from which we can collect carbon samples, and of course this is very important for dating the deposit. So we think that men were probably cooking the results of their hunting excursions, but we know that women were operating in this site too, because we find grindstones with the lower stone that the seed was ground on using an upper grinder like that. So it looks as if this site was a real family occupation place for some considerable period of prehistory.
Aboriginal sacred areas are also evident at the port. They were noted by company engineers before construction and development began, and they will remain undisturbed, despite considerable activity close at hand. very large dredging operation has been deepening the harbour to extend the ship-turning basin. Soon, this stretch of harbour silt will be filled with stockpiles of ore awaiting shipment to the world. Dust suppression is equally important at the port as it is at the mine, because the ore handling installation is close to the town. Dust suppression is now more efficient as a result of tests carried out in the wind tunnel at Sydney University. Dr. Logan Apperley, University of Sydney.
The purpose of the wind tunnel tests is an attempt to reproduce wind conditions that occur at the stockpile site by using models of various together with different orientations to the prevailing wind direction, using a probe which measures both mean and gust wind speeds. These are then used in conjunction with meteorological data for the area, and we're then able to predict the best orientation and shape a stockpile that will reduce the amount of dust.
The vital area of any port is its harbour. To find out the effect of ore handling operations on the harbour and its surroundings, a team of marine biologists was engaged as consultants. Ian Leprovo and Dr. Tim Marr.
To the present time, there hasn't been a detailed ecological survey of the Port Hedland Harbour area. We made an investigation which looked at the exposed tidal flats, which contain the salt marsh areas, through the wooded mangrove to the unvegetated subtidal flat.
Our studies were conducted over a period of approximately 9 months, during which time we conducted about 4 field trips to the area. During these field trips, we were accompanied by specialist scientists who provided expertise in ecosystem description and assessment of the stability of the area.
762.
Since its development, Port Hedland Harbour has been modified by substantial land reclamation of tidal creeks and mangroves, the dredging of approach channels to the harbour, and the construction of shiploading facilities.
People think of mangroves as being just one species of tree, but in actual fact, in any mangrove, the area in which the harbour operations have taken place, and also we looked at the inlet which is adjacent to it, so that from this we could see whether or not there have been any effects on the zonation and distribution, not only of the mangrove, but of the other plants and animals which are associated with these group of trees. A good example of the very tight habitat requirement there are for some animals are the way in which that the lovely old mud crab occurs in rather a particular sort of habitat. You'll find him in the more muddy areas, and also moving up under the old larger logs of the mangrove Avicennia marina. And certain times of the month he'll go up some of the creek channels, other times he'll be back out on the expanse of mudflat areas. Another interesting animal that you get around the mangrove community, which animal to watch with all its little antics that it goes on with, and its very, very strict behavioural regime in which it defends its territory. It looks quite aggressive and comes out in the open even when there's a low tide. But you won't find these animals all through the inlet area. They're in very, very specific locations with very distinctive habitat requirements. And a fascinating thing about this is that not only do the mangrove trees provide habitat for the animals, but it appears from very recent studies that if these animals aren't there, then the mangroves begin to die out. They require the animals just as much as the animals require the mangrove.
To gauge the effect of dredging on marine life, samples of fish were collected from the inner and outer harbours.
We had a range of techniques to sample these animals. We set nets across the tidal creeks. We seined at low tide on Tidal Creek. We trawled at the bottom of the harbour. And we found that our trawling, or the results of our trawling, did not show that there were many animals living on the bottom of the harbour. And we found that most of our fish were collected in the seine netting.
Whilst we were doing the fish surveys in the Port Hedland Harbour area, we were very fortunate to find that there was already a program going on in which the Harbour Board were having to dynamite out one of the old jetties and take out the old piles because there was a hazard. So we utilised the services of the diver and collected all the fish, which he got in the course of blasting. We were amazed to find that in the blasting that went on, that fish species that you wouldn't normally think would occur there do.
The results of the sampling indicated that the dredging hadn't removed a heck of a lot of habitat from the area, because most of the fish, rather than dwelling in the harbour area, actually moved into and out of the harbour area with the incoming tide.
The surprising thing about the big old cod that we caught was that all of them had enormous big hooks inside them. So it looks as if they've got pretty good at sitting under jetty, eating people's baits and hooks and passing them through them.
The mining operation will last for many years, but the environment will last forever. We hope that future generations of people living in the Pilbara region will benefit from our environmental studies, and that the flora and fauna will continue to flourish as a result of this policy of growing with care. A final word from the company's environmental superintendent, Hugh Jones.
Our investigations to date have helped us solve a number of problems and taught us a number of lessons. Perhaps the most important thing we've learned so far is that considerably more work and investigations are required before we can fully understand the complex relationships between our operations and the ecology of this Pilbara region.